station, this is Houston. Are you ready for the event?
I'm ready.
Cases, this is Mission Control Houston. Please call station for a voice check.
Station, this is Greg Johnson at the Bio Conference. Scott, how do you read?
I read you good enough, Box. It's a little bit of an echo, but good enough to do this event today.
Okay, Scott, I want to tell you how very excited, personally and professionally, I am to be sharing you with the audience here at Bio. We have an audience of 3,000 CTOs, CEOs of biotech companies. It's the greatest conference of the year. Tell us where you are right now.
Well, I'm in the U.S. laboratory module of the International Space Station, which the space station itself is currently flying over Australia, and it's nighttime there, so it's dark outside. But this U.S. laboratory module is one of many modules we have on the space station. It's the primary science module on the what's called the U.S. operational segment of the space station. But there are other science modules as well. There's a European Space Agency module, and the science module, and the Japanese have a very large science module. And we do research on other parts of the space station, not only inside but outside, and on the Russian segment as well.
Yes, Scott, I saw your brother Mark last weekend at the commissioning of the USS Gabriel Giffords. I appreciate you tweeting and acknowledging that that great honor that she deserved for her courage and service. And I've got another message from him that I may or may not pass a little later in this transmission. But to get started, what do you hope to accomplish in this one-year mission? You've been up since the end of March.
Well, there are the mission objectives I hope to accomplish, but, my primary goal, I guess I would say, is, do this in a very professional manner for it to be very safe. And, after that, our mission objectives, which are very, very important, and there's different kinds of objectives. Some are science, some are more operational in nature. But I'm sure you guys are interested in the science part of this this flight. And while I'm up here, in this course of a year, there's over 400 different scientific experiments going on. And they're in all kinds of disciplines. Some are exploration based, and a lot of those are NASA type research. But the CASIS research, as you are probably more aware than I am, is more related to how to improve life on Earth, and some of that is with regards to this biotech industry, and the study that we're doing with me and Misha on this one-year mission, and then also with my brother on this twin study, has a lot of applications to things on Earth with regards to our health, and trying to improve our health as we age, because things change up here much more rapidly. So, I hope to accomplish all those goals. There's specific things I hope we learn from it, but in a general sense, get all that accomplished, do it safely, and do it in a very professional manner.
Thank you, Scott. And Scott referred to CASIS, the Center for the Advancement of Science and Space, and I'm their executive director, and in cooperative agreement with NASA, we're furthering NASA's mission on this International Space Station. So we're attracting new and innovative users, commercial users, developing commercial demand for this low Earth orbit commercial market. And biotech is right in the middle of it. So from what I understand then, Scott, as far as the twin study is concerned, and the year-long mission, NASA's portion of the mission is to go to the moon, go to Mars, explore the universe. But NASA also has a mission, and that's where we come in to complement their mission, is to solve problems here on the Earth. And so, as we try to understand how the body reacts in microgravity, we're going to learn how to live in space for longer durations. So, Scott, can you describe some of the physical characteristics that change when you're in space? I have a funny story with your brother that I won't share, but what are some other things that you can share with us that change when you live for long periods of time in outer space?
All right, so I have some stories about you I won't share either then, but I was thinking of it, but since you won't share those that my brother told you, I won't share my stories about you. So, yeah, there are a lot of things that change on our, with our physiology in space that's similar to how people change as they age. The number one that people talk about and that, we've researched up here for a long time is bone loss. That occurs much more rapidly in space than it does on Earth, and it's something similar to what, an elderly person might experience. And from understanding, the mechanism behind this in space and how to mitigate it, we can develop new drugs to prevent that, new methodologies, and that's actually been accomplished already. There are things. There's a drug on the market that was, the direct result of research that was conducted on the space station. Same thing with muscles. We, if we didn't do anything about it, we would lose muscle mass up here. Now, fortunately, we have some good exercise equipment that prevents that. But also from, how that, process occurs here, we can learn things about different types of muscle wasting diseases, and not just learn them with people. Just today I was cleaning up from our casus rodent research we were doing here over the last couple of months, and it was very, very interesting, very successful. There's a lot we're going to learn from that, I think, but we also demonstrated our ability to do that type of animal research on board the space station, which I understand is critical to many of the different kinds of treatments and drugs and things that are developed for people to treat their problems. We have an eye issue, for instance, that is. You asked the earlier question. What's one of the things I hope to learn, and that's one of the things. Being up here for a long time, we're doing some pretty cutting edge research in that regard. Doing a bunch of imaging, ultrasound, a bunch of other scans on the structure of our eye, these devices, OCT, tonometry, while we're in this Russian lower body negative pressure device. Those three things, the effects of, radiation on our physiology is another important one. And the study I'm doing with my brother, the twin study, is going to look at, how this environment, including the radiation, affects us on a genetic level. So, this is really an incredible facility we have up here, a lot of capability, especially with the animal research we have now, especially also with, the imaging technology, the ability to do ultrasounds up here and other types of imaging is really turned this into a state-of-the-art, cutting-edge research facility.
Scott, as you described, one of the great challenges is for us to take the best industry practices on the ground and translate those practices in space so we can take advantage of this one-of-a-kind asset that's up in space, continuous microgravity. You just can't get that here on the Earth. I'm going to slide ahead. We're running out of time, so I'm going to go to question number 5. I'd like you to talk a little bit about the commercial players up there. I understand there's a couple commercial projects right now in the biotech. You talked about the muscle wasting project. Can you share any others that are up there? Because what we have here is an amazing opportunity. Through cases, these commercial companies have access to the space station for the next 9 and hopefully 13 years.
Well, like I said earlier, there's while I'm here, there's over 400 different types of experiments, and my primary responsibility is being the operator of these experiments, which means doing what the principal investigator wants me to do it per the procedure, and get the research done and get the data and get it down to the ground. So, talking about specific biotech companies and specific experiments of the 400 that are on board, I'm really not prepared to do that right now. What I will say, though, is that we have some very skilled operators up here that one of they're very well trained, and their primary responsibility in this area is getting the science done the way the researcher wants, and that's something that I value. I think is very important. I think my colleagues share that, and it's one of the great things about the space station is there's a lot of great things about this place, but one of them obviously is the research we do on board.
Thank you, Scott. And we'll probably talk more about that, the specific commercial examples. For example, Merck has a project up there and others. But we've got one more minute. Before I lose you, what's one thing that we currently don't know that you hope to learn in the next 8 or 9 months that you're up there?
We've had people stay on the Mir space station for a long period of time, a year or a little bit longer. But that was a long time ago. And, not only the Russians, but also us back then did not have the type of imaging technology and, the ability to get the type of data that we can now on, on our human health and performance and physiology. And, it's in the last 20 years, it's really, as the people in that room would know, has really grown significantly. So what I hope to learn is, whether there's a cliff out there. Is there a cliff with regards to our physiology as we go from 6 months to a year or longer? And if there is, how do we mitigate those so we can explore further away from Earth than we've gone before?
Well, thank you very much for your time, and at this point, I'd like to turn it over to the Capcom.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, Cases and Bio International. Station, we are now resuming operational audio communications.